Hi there. This lesson is about 2.1.2, which is even and odd functions. And I would maybe have the ebook available or the book available for 2.1.2. I'll be going through some of the problems from there as well. But we're going to sort functions as even and odd based on their graphs. We're going to define even and odd functions and algebraically verify if it's even or odd. That might be the step up from algebra 2, where we algebraically confirming that. And then 3 is justify why a function is even or odd from a graph, table, or equation. So the first problem they have, 2-16, I did a little of the legwork for you, but they said for each of these graphs, this is f of x equals x, x squared, x cubed, some home graphs that you've seen before. What they wanted you to do is sort these as if they were little note cards. Now what we have is the red graphs are the original functions, and then the blue graphs are f of negative x. So if I have f of negative x, we notice with the linear, I have the red f of negative x went here. With the squared, or x squared, the blue graph is actually f of negative x. So what I would do is pause the video and think about how you would sort these. What are some commonalities? What are some differences? Are there some that you could group together and say, hey, this happened, hey, this happened, and see if you can come up and classify a couple groups and why you put them together. Okay, from there, I'm going to make these a little bit wider so we can see them a little bit better. So you notice f of x had almost like a reflection over the line y equals x, and it had a reflection over, a reflection over the x-axis and the y-axis. The second one, x squared, just overlaid. I did f of negative x, and it was the same graph. The cubic, it looks like it reflected over the x-axis. This red part moved down to the blue, red to the blue, so on and so forth. 2 to the x looks like it reflected over the y-axis. 1 over x looks like it reflected over the x-axis. Absolute value reflected or stayed the same, sorry. Square root of x over the y-axis, cube root of x over the y-axis as well. So there's a couple groupings of theirs, but that's what brings us to even and odd functions. So we want to be able to define those, but maybe if they get a little more complicated, that's what we want you to try as well. In 2.17, it may be worthwhile to pause the video again here and graph x minus 1 squared. Then graph f of negative x. So then I would graph in my calculator negative x minus 1 squared and see if it has any of those characteristics. It would be worthwhile to graph negative f of x for our next slide as well. That if you wanted the negative of the function, just put a negative in your calculator, x to the 5th plus 1, and see what happens there. Because our definitions of even and odd are as follows. In both checking for even and odd, we're going to find f of negative x. So for all those x values, we're switching them to positive or negative. If it's negative, it's going to be positive, positive is become negative, and see what happens with the outputs. If it's an odd function, we say f of negative x will change to negative f of x. It'll be the same function, but essentially every sign will be switched, or it'll be flipped over that x-axis. So negative f of x will have our original function, but everything is negative. An even function, interesting enough, is if I take f of negative x, it's the original function. Same graph, same outputs from even if I put in negative x. So we want to bump up our level of understanding to showing it algebraically. So for example, if I find f of negative x here, if I rewrite this equation as f of negative x, I have 1 over negative x squared. But what we need to dive deeper is understanding some of the outputs based on operations. If I square things, it makes everything positive. No matter what, if it's a negative, negative, positive, positive, it's going to square it. So really, this simplifies just 1 over x squared. Even when I plug in negative x, it makes that home graph, which makes this an even function. Okay. If I have f of x is 5 times x cubed, I'm going to go f of negative x equals 5 times negative x cubed. And let's think about what could happen with that. Let's say my original x is positive, quote unquote positive. If I plug that in there, that's going to make the negative will make that positive number negative. Well, a negative number cubed is going to be negative. So what happens is, if it's the same x value, you're going to get the qubit, and that's going to be the same value. You're going to multiply by 5, it's going to be the same value. So what's going to happen is it's going to have the same value, but the output is negative. If x starts as a negative number, think about what happens. Well, then the inside of this parenthesis will be a positive number. I'm going to cube it, and then I multiply by 5. So again, I'm going to get the same value, like the same number, the same output number, but the output is positive. So what we see here is that 5 times negative x to the 5th actually ends up being negative 5x cubed, which then is negative f of x. We can try some more that make maybe look a little more challenging. I got an x to the 6th, so if I have f of negative x, it's going to be negative x to the 6th minus 1. Now, similar to when we had squared, when we take things to the 6th power, they're the same output as x to the 6th. So this is x to the 6th minus 1, even. I'm sorry, I forgot to call this an odd function. And then we have a little more complicated, so we can verify if it's even or odd, or maybe it's neither. So if I have f of negative x, it's going to be negative x minus 1 all quantity squared. And let's see what that does on our generic rectangle. Let's simplify it, see if it looks the same. I get negative x minus 1, negative x minus 1. Some quick multiplication here. I get x squared, I get x, and then I get an x, and then I get a positive 1. So I would get an x squared, I would get a positive 2x, and I get a plus 1. If I expand the original, or I guess I could factor this. Let's factor it. This is actually x plus 1 squared. So it is different. So this is a neither. So there are ways of finding if it's even or odd. Algebraically, we want to verify it does get to the original function, a description of y gets to the original function, or an even showing that it will end up as negative f of x. So we wanted to also verify, take a look at some different representations and how we can check if it's even or odd. For each of the following functions, even, odd, or neither. And what I may do is find some inputs and outputs. For example, I want to find a key input and output on this. Let's go right here. It's an estimation, but let's say when x is 1, let's say when x equals 1, my output is negative 3. So if I'm going to check if it's even, odd, or whatever, I'm going to have to find negative x. Well, negative x is see, well, when is x equal to negative 1? Okay, when x is negative 1, the output is 3. Interesting. Interesting. So let's try another one. Let's say when x is 2. When x is 2, y is 0. Okay, so now I got to check for even or odd, what's a negative x? Well, when x is negative 2, what do I get? I get 0. Well, that doesn't help me out because that makes it look like it's an even. This makes it look like it's an odd. So we might have to try a couple more. 0 is always a tough output for that. What might be another good one? Let's try, we could try a half even. X equals a half. We don't have the function, so that's okay. But it looks like the output is about negative 2. So I want to see what happens when x, or negative x, see it at negative 1/2. Negative 1/2, I have an output of positive 2. That's more of an indicator for me. Notice that when I get this output, when I put in negative x, it gives me the opposite sign. This is an odd function. I know it's tough to see with the 0 because positive, negative, 0 doesn't really give me an indicator. So try a couple other ones. This is an odd function because f of x, or sorry, f of negative x, showing me that it's negative f of x. Okay, over here to this, looks like a negative cosine curve. looks like, yeah, from 1 to -1. In this piece, let's try pi. Let's say when x equals pi radians, it has an output of 1. That means I got to try when it's a negative x. When is x equal to negative pi? Well, that's over here. Ooh, I get a +1. We can try some other values at 0, -2. We could try here at pi over 2. Again, that pi over 2 gets me 0. At negative pi over 2, it gets me 0. We can try 3 pi over 4. But notice if I have 3 pi over 4, and I go to negative 3 pi over 4, I'm getting the same values. So this is an even function. When it gets me that same graph, it's an even function. Looking further down into the tables, C, D, and E here, let's try -3. Okay, I plug in -3, it spits out 16. Now I want to do f of -x. Well, that would bring me over to 3, and it spits out 8. Okay, spit out 8. It has no relation. It's not a positive or negative. It's not the same. This is definitely a neither. Okay, D. Let's try -3. It spits out -2187. Negative x, or f of -x, means I got to plug a -3 and I get 3. At 3, it spits out 2187. Ooh. Notice -128, +128, so on and so forth. So this is an odd function. It finds me negative f of x. Right? E, if I do k of -x, I get -x to the 3/2. We could look at this differently if we wanted to. We could call this the square root of -x cubed, which will not get us the same values every time, okay? And you can always try some values to see if it gets you to one or the other. Similar here, f, the absolute value of x cubed. If I take f or m of -x, I would get the absolute value of -x cubed in parentheses. All taking the absolute value, but that's another very powerful operation. So even though I have a -x, hey, I got to worry about the sign. Negatives cubed remain negatives. Positive cubes remain positive. But at the end result, guess what is always going to be positive. So this is one of those where you get the same output, you get the same value, the same number, but it's always going to be positive even if it's negative. So this is going to be an even function. It's going to look like the original, even if I plug in -x. So hopefully this helps. Again, we have multiple representations. Work on the algebra of showing and thinking about those operations that make positives, positives, negatives, negatives. And if we can take the square roots of negatives, things like that. Hopefully this helps. Have a great weekend.